Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about Orbital Reef Space Station. So let's dive right into it. Now, this puppy is supposed to be next ISS, meaning ISS at this point in time is very serious danger because I'm pretty sure you are aware of something known as Russia, and it's also about age, meaning ISS have actually served its expected lifespan, meaning it's supposed to be working for 20 years, and that 20 years have passed, meaning at this point in time the solar panels have been degraded to a point where your new solar panels have to be attached, and whole system is becoming too degraded basically. Astronauts right now is spending significant amount of their time into repairing this puppy. Rather than using this, they are spending time on repairing it. So it's about time and again political danger. And the biggest issue for politicians is that this puppy is too expensive at this point in time. It's too goddamn expensive. Again, first, it's like a Mark 1 product. Mark 1 products are generally like this. Now, NASA wants to do something very simple. They want to rent space in space. They don't want to build this whole thing again. They're just like, can somebody please give me something where I'm like, here's my money, give me the space, done, go home. They want to do that, basically commercial option. So commercial LEO destination project was created a few months back. Now they have been working behind it's a very low level project. It's like something that we are planning. Basically it was a seed project that's supposed to blossom into something awesome, like basically how commercial resupply mission blossomed into SpaceX. They're supposed to do something similar. So basically NASA is planting seed. At this point in time, it's early stages, meaning NASA is only gonna pay for design development, meaning let's say 40-50 people are paid for this design. It's like, this is our design, we want to develop this. NASA will fund them based on like, hey, I think this design has some potential, here's some money, do final research on it, like, completely flush it out. And then there will be next stage. And NASA is only supposed to give seed fundings. They're not supposed to give 100% of the cost of building it. It's not supposed to be next ISS. It's supposed to be a private venture where NASA is just like just helping it along, so to say. So we are talking about next ISS. Now, Orbital Reef is one of the really good design and big far out design. It's a Gen 4 space station, meaning Gen 3 space station is basically you have modules and you're just docking them modules. Gen 4 modules are where you are assembling them in space in some unique configuration. For example, space station, it has that power truss structure. So you have like very complex integration. So this is a Gen 4, can be classified as Gen 4 station, and it will be built around the core module. Now, core module is this one like big, huge, hard thing. And it's kind of huge simply because it is 7 meters in diameter design wise. Now here's the problem with that. There is nothing right now, as in like just take my money and launch something 7 meter. You can't actually do that. There is nothing that has that kind of fairing clearance inside. So it needs New Glenn rocket. Now if you don't even know about New Glenn, I will not be surprised. It's Blue Origin rocket that's supposed to be launching by now, but again reasonably behind schedule. So that's the core idea behind it, meaning they're gonna build the core and everything will be attached to it. The core will take care of basically everything. And because Blue Origin is dealing with this, they are also gonna install Amazon level computation platform into this, meaning after ISS people realize you need a lot of sensors and you need a lot of monitoring. Now right now ISS is being monitored by a lot of people. Peoples are expensive. You want computer to monitor everything, and if there is an anomaly, computer forwards it to a person. So it does require a lot of computational horsepower, so to say. Now who has that kind of experience dealing with like high horsepower computation? Amazon Web Services. So that will be also provided in the core structure. So core module is the 7 meter diameter system, which is huge. Be mindful, it's like almost 40% more diameter, so it's huge compared to ISS. Inside is like it's huge, it's gonna be huge. And core is hard, meaning it's hard shell structure, and others will be inflatable design. Now be very mindful, there is right now it's very early design, so how many inflatable designs they will have, how many hard modules they will have, that could change. But current analysis is that they're gonna have research module, which is gonna be hard module, so they can have big heavy things there which may require a bit more oomph. So research module will have something like that. Basically for manufacturing purposes you may want like something that is a bit more robust, and for people living and all that you want something that is more spacious, because space is something that you require, and ISS in like it's a very very claustrophobic. You don't want that, so you need space for people. So life module is a basically inflatable module, and even one of that puppy should be able to habitate 10 person comfortably. That's huge compared to ISS. And this whole unit is modular, meaning this is one U, and you can attach, like this example, 4 U have been attached. You can attach to, like, of course there is an upper limit, you can't just like add 20-30 of that, but they can extend it to very significant limit. And this is the whole space station. Basically This at this configuration, space station is ready. It's just at 1U. You may want to add another if you want it, if it's profitable. If it's not, just this enough on itself is enough. It has 100 kilowatts of solar array. Again, the advancement in the solar system. It does have cooling radiators. Now, this is one thing you have to understand. Space is very hot because you are surrounded by perfect vacuum. And if you have 100 kilowatt of energy going in, it only gonna radiate through the surface, and you are limited by the surface. So fundamentally, you do need radiators. And if you are doing any sort of manufacturing, there is a very good chance you need heat and cool. So heating is super easy, but cooling, how the heck you're gonna cool? So it does have a huge radiator, and they design it in such a way that even in worst case scenario, it should be able to cool heavy industrial processes. So life module, research module will be attached based on the requirement. Basically, let's say for example, in future they're finding like research people are not paying that much for it, but space tourism is going YOLO. They will add more inflatable module based on the desire and demand of the market. Now, what about the partnership? Basically, who is building this? Flat out, there is no single person who can afford to do this, not even Jeff Bezos. So Blue Origin is the backbone provider. Sierra Space is like brain provider, quote unquote, because they have the only one that has actual space worthy spacecraft, so to say. Because this is not classified as space worthy. This is not human rated, but the primary reason is not is funding limitation. That has been sorted. Once they are into this competition, they have raised a lot of funding for that. So soon it will be started to go through the process of human rating, and it has flown enough time in space that's like they have something, they have enough foundation there. And Boeing will also provide their craft. And now you may be like, okay, this is an American system, why the heck there is no mention of SpaceX? The whole animation, the whole video, and nothing there is no SpaceX. The reality is SpaceX is kind of becoming a problem for, well, every other company, simply because even for NASA invested in multiple companies. There's supposed to be multiple people. Why the heck there is only one? Like, why the heck Boeing, which worked on Saturn V goddamn project, somehow cannot get a simple capsule to work properly? It's like, how the heck that's happened? How the heck other companies like ULA, who like basically it was ULA's jobs to make a new rocket that has its own engine, but rather than contracting other people, they contracted Blue Origin. Why the heck Blue Origin failed to deliver engines on time? Again, so NASA did try to have multiple options, multiple competitors, but only SpaceX survived. And that's very tragic for a country that's supposed to have like around 50-60 space companies. So that's why this Orbital Reef project is like anti SpaceX. Not because like SpaceX, if they approached SpaceX is like, no, I'm not going to attach you. No, SpaceX would be happy to join in, and again, they may even want to join it. But right now, they basically, all other companies want to show that USA exists even without Elon Musk. That's what they want to do. So that's why you do not see like Dragon right now. They will show this, not Dragon. Now NASA is also taking care of the seed funding. However, because Sierra Space, again I said, they are providing the brain power, they know for a fact that there is a risk that we may end up using Falcon 9 only because no other rocket is ready. They are also dealing with JAXA, meaning Japanese space agency, and JAXA will provide a rocket in case Vulcan is not ready on time for this puppy. So at this point in time, there are two nations that have already signed in, and not to mention Arianespace is also in talks at this point in time. So it will use international docking adapter. Primary reason because it's cheap, because again it's already been developed. Like your Dragon is already developed, this is also developed, Starliner is also developed, and Starship will also have international docking adapter. And any upcoming nation like ISRO or things of that nature wants to, if they want to develop something, international docking adapter, and they can work with anything else. So that's there. So this is the whole aspect of it. Basically, Boeing is providing the launch system, Sierra Space is providing the launch system. They do not want to be in the situation where Dragon is the only option. They never want to be that single point of failure. That's why these two craft from day one, like from day one animation, they're like, these two people will take care of it. So in case one goes YOLO, other will take care of it. If this goes YOLO, this will take care of it. Ideally, that has not happened yet, but that's the whole point. And SpaceX can join simply because, let's say, people who are renting there are like, dude, I like the space station you have built, and I would like to join it, and I will be willing to pay you, but I need to find a cheaper rocket to actually come to you. For example, Dragon capsule. They're like, yeah, because let's say Boeing, even though let's say they've successfully built it, it would be idiotically expensive. So they're like, you know what, I can't actually afford this. And this may be pre-booked because again it is a complicated system, so it may be pre-booked. So they are like, can I come with Dragon capsule? Yes, that can be done. That's the whole point of international docking adapter. And another core aspect that people have learned from ISS is that sometimes you need people outside of space station, and to manage and monitor things. In those sort of scenarios, current spacesuit that people are using right now, they are too expensive and too limited, meaning they can't actually do much, and it's very brutal on the astronaut, so to say. And primary reason for that is the pressure. It's not mechanically pressurized, it's air pressurized, meaning 100% pure oxygen. Now that creates multiple problems. First problem is that your body is not designed to run on 100% oxygen, so it does need what we call pre-breathing, meaning before you go from one atmosphere of ISS to outside of basically spacesuit of 100% pure oxygen at lower pressure, your body needs to degas the nitrogen. That does again, it's something doable. It is done by sea divers and all that jazz. It's a known thing, but it does take time, meaning even something that will take you like 5 minutes to do on this outside, you just go there, connect this power coupling, come back, that could take 3 to 4 hours grand total. So that slows down actual progress very significantly. That's one thing people learned from ISS, that spacewalks are not something that you can just like done. It's not like Gravity movie where she's just changing spacesuit to left and right. Yeah, that's not gonna work. So they were developing the single person spacecraft. Now this is basically big enough where it has the docking adapter at the bottom. So you open the docking adapter, you go float inside it, done. You lock it up, and it acts as a complete system, meaning you do not have hand ports where you're gonna use your hands, but it has like 3 arms. Now why does it have 3 arms? Well, again, people have found many times you need that third option for holding something, or like if you are attaching something, you do need 2 arms. We are used to 2 arms, but sometimes we always need that third thing, and because there is no gravity to lay things on, we need that third option. That's why 3 arms are designed, and it can be done remotely also. Be mindful, this craft can work remotely also, and most likely the first few outings will be remotely only. And it does have huge propellant depot. Propellant not as in like a liquid propellant, compressed nitrogen will be utilized, because this will be very flying around space station. If it uses like hypergolic fuel, it could damage the solar panels. It could just the exhaust would be dangerous, and it's gonna fly around the space station, so it could harm the space station. So that's why it has to be a nitrogen system. And all the capacity, like basically the space here will be filled by equipments, life support system, communication system, flight computer system, telenavigation system, all that jazz. Basically it will be done there, and it will have 3 manipulators arm, which will have something like this supposed to be good enough for basically everything they need to do. And because these two things are being developed in conjunction, they are designed in such a way that these things would be sufficient enough, meaning ISS, when it was built, it was a bit more human oriented, because they know people would be outside, so it was only designed to be working with gloves. But again, these hands are not as dexterous as this puppy, so they are designing everything on the outside of the space station to be workable with these puppies, not need something that you need human hand. Again, they may have spacesuit, they may add it as a very good experience, prime experience. They will add like spacesuit, people going outside, but this will be the main workhorse. Space suits will be used in case of emergency, or sometimes again other things. But this is the another aspect. Without this puppy, they will not be able to make their space station big. Now, what are the timelines? Timeline at this point in time, one section, I specified there are multiple sections repeating. One section should be ready by 2030 at least. That's the worst case scenario. It should be ready at that point in time. And what NASA actually wants is basically overlap before ISS is completely retired. They want a overlap, meaning ISS overlapping. They don't want it like this. They want it like the air. They want like a little bit of redundancy, and deployment will take time, because again, even though it's a very simple design, it only needs 3 launch. One of the supplier has never actually reached orbit, so people are like, yeah, I get it, Jeff Bezos have boatload of money, but does not have a rocket that actually goes to orbit. So that's a very serious thing. Now, funding backbone supposed to be private. This is one thing very clear from day one. It's not a NASA project that NASA is funding for. It's not like that. It's something that NASA is just helping along, not building the whole thing itself. And LEO manufacturing should start by 2030, because right now there have been many objects that physically can be built, but ISS is not good enough place, simply because again ISS is too small, too cramped, and it was not built for that. It was Mark 1 product. This is a Mark 2. From day one they are designing in such a way that's gonna have huge space. So if you want to experiment with 3D printing organ, which is a very lucrative market, if any puppy can crack this, they're gonna print money like there is no tomorrow. Imagine it this way, like you have a heart failure, a minor issue which can be treated with surgery, but it will always have this issue or that issue, or you just pay a boatload of money, get your heart printed, tada, done. Now you can't be like, why can't we print heart here? Well, we can. It's just gravity has a feeling of crushing it, so to say. So that's why it has to be done zero space. I'm saying zero gravity. So time, like that manufacturing is very key here. And any company who starts to like offer space is like, hey, do you want to do something amazing in space? We have the place, rent it from us. Movie shootings, again, that's supposed to happen right now. I'm not supposed to talk about war, god damn it. I'm supposed to talk about war movies, not actual war. But again, things happen, life happens. So that's the target, that's the end goal. Let's see what happens. So this was my presentation on Orbital Reef. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.